Good morning, children. This is class 12th physics, chapter 4, magnetic effects of current. Okay, so today, children, we are going to cover the topic force on a current carrying conductor. And in this, we will see Fleming's left hand rule as well. So force on a current carrying conductor means here you are having a conductor, a wire through which current is flowing. Now on that wire, how much force will be acting by the magnetic field as well as due to electric field. So we will see, children, in the previous class we saw that when a charge, a positive charge, moves through electric and magnetic field, it experienced a force. Now instead of that charge, we are having a whole wire. So we will calculate the formula for the force on a current carrying conductor which is placed in magnetic field. Right, children? So here in this diagram, we can see that here this brown color is your wire, right? And in this wire, we can see that the direction of current is in the z direction. So this is our z axis. So the direction of the current is in the z axis. And the electrons, we know, they move opposite to the motion of the current. So the velocity of the electrons is in the upward direction. So this is the velocity of the electrons, and Vd means drift velocity of electrons, right? We have done drift velocity in chapter current electricity. Now the magnetic field, the external magnetic field, we are applying in the x-axis, right? We are keeping the north pole and the south pole of the magnet from negative x-axis towards positive x-axis. So the direction of external magnetic field B is along the x-axis, right, children? So this much we are having. So chalo, what we are having? We are having a wire, yes, and area of the wire is A, length of the wire is L. This much clear? Okay. Now, the number of free electrons per unit volume means, children, in this wire, if we select one small cubic volume, this 1 meter, 1 centimeter cube, छोटा सा हम एक क्यूब निकालते हैं. In that cube, beta, if I say there are n number of free electrons, then what is the total volume of the wire? ये पूरी जो wire है इसका volume क्या होगा? We know that volume is always area into length. Area into length, because area is meter square, length is meter, and if we multiply this, we will get meter cube. Meter cube is what? Volume. So area is volume is area into length. So this is the total volume of the wire. So for unit volume means, for volume 1 meter cube, the number of free electrons are n. Then for volume A into L, what would be the number of free electrons? Simple maths, cross multiplication, that is NaL. So children, NaL are the total free electrons in the wire of volume A into L, right, children? So that is the total number of free electrons. Now we know that charge is Q. Q equals to Ne, we know, right? This we have done in class 10th. Q equals to Ne, where N is what? N is the number of free electrons. Oh, that we got. They are this NaL. That is the value of N. So we'll put total charge is Q equals to, instead of N, we will put NaL, and E is there. This is E. So this is the total charge that is moving in the wire. So how many free electrons are there in the wire? The total free electrons are NaL. So what is the charge? Charge is number of free electrons into E. E is the charge of one electron. So it is minus NaLe. Why minus? Because electron is negatively charged particle. Right, children? So this is charge Q. So this much, I hope it is clear. Now we know the formula we had done in the last class, that if a charge Q is moving, then the force on charge Q is Q will be sine theta, or you might remember like this, Q bracket V cross B. Yes, you remember this, F equals to Q bracket V cross B, and if we remove cross it would be sine theta. So the same formula is over here, F equals to QVB sine theta, and here F we have taken it as small f, right? Now, if I say instead of charge Q, I am having an electron. So can I put here E for electron instead of charge Q? Yes, we can put. But here, this is the charge on one electron. This is the force on one electron. But how many electrons we are having? We are having the total free electrons, or the total charge. If you remember, the total charge is Q, capital Q. So the formula will become, instead of E, we are going to have Q and V. V is velocity, and here we are going to have the drift velocity of electron. So it is Vd B sine theta. So this equation can be written as QVd B sine theta. Now the value of Q can be taken from here. Instead of Q, can I write minus NaLe? Yes. So instead of Q, we are going to substitute as minus NaLe. So here you can see we have substituted minus NaLe instead of Q. Rest things are same, that is Vd B sine theta. Now what we are going to do is, over here we are going to remove L from here. L is going to come out of the bracket and Vd is going to go in the bracket. Why? Because when it goes in the bracket, it will become NeAVd, which is nothing but that is equals to the current I. If you remember, it was I equals to AVNE. You can remember in terms of Avni. I is your current that is flowing through the wire, that is AVNE, and your velocity is your drift velocity. This is from the chapter current electricity, right? So instead of that, we are putting over here I. L. This is L which we had taken out of the bracket. B sine theta. Now it's sine theta, so instead of sine theta, we can put cross product. So cross between L and B. So L and B are vectors. Now we are familiar with the vectors. So this is vector F equals to I vector L cross vector B. So where theta is the angle between these two vectors. So which are these vectors? L is the new thing. L is the vector of magnitude L, right? L is the length of the wire. Why we have taken it as vector? Because here it is going to have a direction, and its direction will be towards the direction of the current. So children, this is the formula for the force. This is the formula for the force on a current carrying conductor or wire when it is placed in magnetic field. That is vector F equals to I bracket vector L cross vector B, or you can write it as F equals to ILB sine theta. So इतना फोर्स उस वायर पे जिसको आपने मैग्नेटिक फील्ड में रखा है उस पे इतना फोर्स लगेगा, and because of this the wire will get turned. Because of this the wire will show some change in the position, right? So let's move further. And here children, so this is the formula of the force, that is ILB sine theta. Now here two cases are possible. Let's take, suppose the theta is 0 or the theta is 180. So if theta is 0 or theta is 180, we know the value of sine theta or sine 180 is 0. So ILB sine 0 is 0, so the force becomes 0. So children, when your conductor, your theta is the angle between your conductor, that is your wire, and magnetic field. So your magnetic field is in this direction, and suppose you put your wire, this is your dabba is your wire, right, your conductor. Now here you can see that the wire is also in the same direction. So when your conductor and the magnetic field, they are in the same direction, or the current is flowing like this, or minus or 180 degree, then the force between them will be 0. Means the conductor will remain as it is. It means that the linear current carrying conductor, when placed parallel to the direction of magnetic field, experiences no force. Right, children? So here they are going to experience no force. Now the next case, that is when the theta is 90. So we know sine 90 is 1. So if we substitute that value, then here we will get the force as maximum, that is ILB, right? So it means that the linear current carrying conductor, when it is placed perpendicular to the direction of magnetic field, means your conductor and magnetic field, they are perpendicular to each other, then it will experience maximum force. And when they are parallel, you know, this is your conductor or your wire and magnetic field, as I explained you before. So angle between them is 0, right, or 180 if the direction of current is this. And if they are parallel, suppose this is your wire and this is the direction of the magnetic field. Sorry, now we are talking about perpendicular, है ना? And this is the direction of magnetic field. So children, they are perpendicular to each other. So this is the point when they are going to experience, when the wire is going to experience the maximum force, that is F equals to ILB. Okay, now force we know it is a vector quantity. So magnitude to pata chal gaya, that is ILB. Okay, sine theta. But what will be its angle? So children, angle was given by Fleming left hand rule. So what does Fleming left hand rule says that children, stretch your left hand as shown in the picture. So according to Fleming's left hand rule, if the first finger, that is this finger, if the first finger, that is this finger, points in the direction of magnetic field, means you are keeping your first finger in the direction of magnetic field, and you are keeping your middle finger, this is your middle finger, right, and you are keeping your middle finger, center finger, in the direction of electric field. You are going to stretch and you are going to keep them 90 degree perpendicular to each other. Then the thumb gives you the direction of the force experienced by the charge. So thumb आपको बताएगा that किस direction में wire के ऊपर force लगेगा. So this is your Fleming's left hand rule. So you have to stretch all the three fingers perpendicular to each other 90 degree. Right, children? So this is your, this will give you the direction. So let us go for the direction in the diagram number 1. See, in this diagram, we are going to stretch the first finger in the direction of magnetic field. So we should keep our first finger in this direction, right? Then the middle finger in the direction of electric field, right, in the direction of current. So current is going in Z direction. So you will keep the middle finger in this direction. Then your children thumb is pointing in upward direction, right? So this wire will experience magnetic force in the upward direction. So the wire will move along the upward direction, that is along the y axis. Right, children? So this was given by Fleming's left hand rule. Now, the next topic is force between two parallel current carrying conductors. So suppose you are having two wires which are placed parallel to each other like this. See the diagram. Here you can see the black wire and the red wire, black wire, red wire. You can see the coil of wires. In this coil of wires also, the wires are placed parallel. See this spiral of wire. See this wire. So in all these cases, the wires are placed parallel to each other. So when two conductors which are carrying current, when you're placing them parallel, then they will exert a force on each other, right? वो एक दूसरे पे force लगाएंगे. So it can be attractive force, it can be repulsive force. It depends, that we will see, right? So in this case, what is known to us? We should know how much current is going to flow in each conductor. हर एक wire में how much current is flowing. Plus we should know what is the distance between the two wires, right? With this knowledge, we will proceed further and we will calculate the force that is experienced between two parallel wires. When there are two parallel wires, how much force will they exert on each other? Right, children? So this we are going to see now. Okay, so here what we are going to consider, let's see what is this much is okay. So here children, we are going to consider two very long wires. So these are our two very long wires. This is wire 1, this is wire 2. We have named them as X and Y, right? Now the current that is flowing in wire X is I1 and the current that is flowing in wire Y is I2. And the direction of the current in both the wires is the same. The wires are kept at a distance of R between the two. Okay, so children, as here we can see that the two parallel wires which are carrying current, they are placed in magnetic field, right? Here the magnetic field you can see it across has been put, means the magnetic field B is into the paper. It is inside the paper, right? It is in the plane of the paper. अंदर की तरफ है, paper की तरफ है, नीचे की तरफ है, right? Okay, I hope these things are clear. Now let's move further. Now we are going to consider this point, that is point P. So at this point P, the magnetic field we are going to calculate due to the wire I1. So children, as we know that in the wire X, the current I1 is flowing. So due to this current in wire X, that is I1, magnetic field will be produced at point P. इसकी वजह से magnetic field वहां पे induce होगी, produce होगी. And what would be its, how much it would be? It would be B1 equals to mu 0 I upon 2 pi R. We are familiar with this formula, right? This is the magnetic field at point P due to the wire X carrying current I1, right? This is it. Now, the force, the magnetic force on the current carrying conductor, we have done this magnetic force, current carrying conductor, the previous topic, that is ILB sine theta. We know this, that is the force magnitude, right? That is ILB sine theta. So suppose if we want to calculate the magnetic force for this wire carrying current I2, then the formula for the force will be F2 equals to ILB sine theta. The formula for force will be F2 equals to I. Current कितना था wire 2 में? I2. L B magnetic field कितनी है वहां पे? B1 sine theta. Now here beta L, the length we are considering as at 1. So the formula will become F2 equals to B1 I2 sine theta. Right children? Now if we take theta is 90 degree, then we will get the value of force as B1I2. Why we are taking it as 90 degree? Because children, here the wires are kept parallel to each other. Right, children? The wires are parallel to each other. So the angle between children L and B, they are perpendicular to each other. So the angle between L and B will be 90 degree. So we'll get F2 equals to B1I2. Right, children? Now this value from of B1 we will get from the previous page, that is this. B1 equals to mu 0 I upon 2 pi r. So this value we will pick from here and we will substitute in this. So you will get mu 0 I1 upon 2 pi r and you are having your I2. So this is the magnitude of the force that is experienced by the wire 2. And its direction can be easily found out by Fleming's left hand rule. ये rule से बेटा हमें direction पता चल जाएगा. Magnitude इतना है, fine. The direction will be given by Fleming's left hand rule. So you have to stretch all the three fingers perpendicular to each other, right? And you are going to place the first finger in the direction of magnetic field. Now you saw that the magnetic field is into the paper. तो वो जो फर्स्ट फिंगर है वो नीचे की तरफ हो जाएगी, राइट चिल्ड्रन? इट विल बी इनसाइड द पेपर, इनटू द पेपर, right? Then the middle finger will point in the direction of the current. So children, we know the direction of the current. Direction of the current is from down to up. So I think you need to rotate your hand. So it would be from down towards upwards, right? Then the thumb, which is pointing towards the left. Then the thumb that is pointing towards the left, that is, this is the direction of F2. Right, children? So this is the direction and this is the magnitude of force experienced by wire 2. Right, children? Now, similarly, now we are going to consider at point Q, and this point Q is on wire 1. ये देखो यहाँ पे है ना Q. Now, इसमें करंट क्या चल रहा है? I2. Because of this current at point Q, magnetic field will be produced, and that magnetic field will be beta B2, right? So that magnetic field is B2. Similarly, we are going to do as we did for the other one. So at point Q, the magnetic field is given by mu 0 I2 upon 2 pi r. Why I2? Because that magnetic field is due to the wire, the other wire, and the current in the other wire is I2, right? Now, the force that it is going to experience similarly will be B2 I1 sin theta. Theta is 90 and you will get here F1 equals to B2 I1. Substituting the value of B2 in this equation, we will get this. So this is the magnitude of force, and direction of force can be found out by Fleming's left hand rule. So the direction of force was found out in this direction, that is F1. So F1 was in this direction, F2 is in this direction. So aren't they, children, attracting each other? So from this we can conclude that when the current is flowing in the same direction in two parallel conductors, they will attract each other, right? So here you can see two wires, the direction of the current is same. So they are going to attract each other, and when the direction of the current is different, here the direction of current is in upward direction, here it is in downward direction. There are two parallel conductors which are placed some distance apart, so they will repel each other. Right, children? So here, if you remember initially when we started, we had considered infinitely long wire, right? So this formula, whatever we have derived, force formula, mu 0 I1 I2 upon 2 pi r, right? That is for infinite length wire. Because if one length is infinite, then we will compare it with the other of finite length. So suppose the length of the other wire is L, which is carrying the current I2. So the first wire will behave as an infinite length, which is formed from this piece of small wires. So the total magnetic force can be given as mu 0 I1 I2 upon 2 pi r into the length of the wire, that is L. Okay, so this is it, children.